Okay, and looks like we're live. Hello. Today we have more board repairs. More board repairs. There's a mountain of board repairs to do right now. I'm not complaining. I'm gonna be here late though. So I figured let's do a stream. Kill two birds with one stone. Kill some time. So I've got a bunch of potential TriStar issues in the shop right now. So first is an iPhone SE, the dreaded iPhone SE TriStar. I quote hire to repair charging issues on the SE. Based on the physical layout architecture of the phone, they put the TriStar and Tigris charging chips right next to the NAND, and they like to underfill them in this really tough, hard, sticky underfill. It's just kind of a nightmare to deal with, honestly. So I charge extra. And if it's not worth fixing at that price, I'm okay with not fixing it. but we gotta bite, we gotta take her. This one's important, so let's go through the initial diagnosis and work from there. So we have an iPhone SE, as you can see when I plug it in. We're gonna pull really low amperage. It is powering up. It's always a good sign. We like to have some signs of life, but 0.2, 0.17, spiked up to 0.35 at times. That's really not enough. This thing ought to be pulling an amp or more while it's booting. Let's let it boot all the way up, and then we'll let the screen time out, and we'll see what it's actually charging the battery with. While your screen is on, the phone's designed to run off a USB power. So it's not going to actually pull battery amperage while it's plugged in, or it shouldn't at any time. Right now we certainly are, because it actually uses quite a bit more than 0.2, 0.3 to even boot. That's why we're always looking for somewhere in the neighborhood of a whole amp. Well, I guess it would help to plug in the home button. That's a pain in the butt on the SE. When you gotta dangle on like this, you gotta fish this little guy off of the charging port and connect them together. Well, we do have screen timeout, and we're 0.11 to 0.15, and our battery is reporting 86%. So it's not going to be pulling a ton, but it should be pulling more than that. That's no good. With the battery that was in this phone when it came in, it had depleted to the point of not even powering on. So it's still pulling like 0.1. So this one's not charging enough. So this is a candidate for TriStar replacement. Couple things to check on the SE, especially the SE, because it kind of shares some design cues from the 5S, which is what it looks like, but the underlying architecture of the motherboard is actually the 6S. So I think we might actually luck out, not have to do anything crazy. Oh, I suppose you'll want to see what I see. Oh, there you are. And do you see what I see? Let me explain what I see. Let's zoom in a little bit. Okay. You see these couple of little fellas just plopped around? This is, we'll use the word classic. battery removal damage. You slide a tool in there without being careful, you'll get this. And let's look at what those do. First we'll need to... Okay, we want iPhone SE. Alright, and where's our battery connector? Over here. There we go. Alright, these little fellas here. FL2400. If you ever see something labeled FL, it's important. It's a filter or an inline fuse. It is bridging the gap for data to travel from this side to this side. In this case, this is our battery single wire information line, SWI. Tigris battery SWI con, Tigris 2 battery SWI. So this line talks to Tigris. Tigris is located over here. Ooh, where you at, Tigris? El Tigre. Where? That's interesting. Where are you? You're supposed to be here. Tigris isn't somewhere else on this phone. No, that's Tigris. Alright, well, maybe our board view is jacked up. Tigris battery. Did I do a dumb and click on the wrong side? Here, connector. Okay, so this is your battery information line. For whatever reason, it's not. And maybe I'm an idiot. I wouldn't argue that at all. Oh, here we go. Yeah, comes over here, and then it talks to Tigris. So it goes through a pair of resistors after it goes through this little Q2301. Alright, so you got a lot of stuff basically around the battery connector that feeds information from the battery to Tigris. So what do you think happens? Let's get the good tweezers. What do you think happens if you knock a filter off while you're removing the battery? Well, it's kind of obvious, isn't it? It's gonna interrupt the phone's ability to send that data where it needs to go. Now, unfortunately, it looks like, let's see. It looks like we may have pulled a pad. I'm not 100% certain of that. Is that getting shiny? I think it is. Maybe we didn't pull a pad. Maybe we can set these right back where they need to be. And if that's all it needs, then we kind of dodged a bullet here. I was actually looking forward to this one because it's been a while since I had to dig out all that brutally aggressive underfill. And I wanted to show you something special on this particular phone, which I think we still will, because it's worth celebrating. Oh yeah, okay, well, we've got the funk. Let's get our filter mounted first. As you can see, our capacitor wanted to come play too, so it's gonna need a good touch up anyway. So let's work it as well. say a quick Hail Mary here, just to solidify the chances of this being a real simple gas gauge repair and not a whole iPhone SE TriStar Odyssey. Ah, that ground plane doesn't want to play ball, does it? Alright, well, let's get the important one on. Of course, my iron looks like trash now. Let's get the filter mounted. That's the money shot right there. That's the one that's doing all of the work. In this configuration, the capacitor is there just for smoothing the data line out. If it gets a weird spike, that cap will buffer it to ground. Let's try it. Let's try the tweezers here. There's actually way more science behind this battery SWI line than I'm letting on, and I don't fully understand all of it. I do know enough to know when the filter is loose, that is not getting where it needs to go. Okay, you know what? We're just gonna put some new solder down, and I'll do this with hot air. Let's see. Little things are eating my lunch right now. Okay, that's our filter. A little bit more flux since we're getting dirty. And some nice fresh clean solder. That's our ground. And because these things want to be little turds, we'll just put them down without air. And that'll be that. Put a little bit more flux to try and protect this connector. I don't want to bubble out all the plastic on it. Come on, little fella. Might as well grab our cap. We stuck to the side of the connector there. Come on. Get where you're supposed to be. Okay. Well, that looks like shit. Let's stick with the plan of having work that doesn't look like shit. Yeah. Something, even the best laid plans, right? cool off. Yeah, now we got a nice big old pool of nasty flux in the battery connector. Clean that up real good. I want to make sure we didn't end up with some kind of weird cold joint or anything on this. Make sure we have a nice effective connection there. I'll tell you what we did effectively hit. There goes our liquid damage indicator. Usually either pink or red. Black indicates, I don't think anybody's going to happy to see a black LDI. Alright, let's give this a touch. Alright. We'll go back to the schematic and we can just double check. You want to check, you're checking a filter, you want to check whether that filter is in the right place. Oops, here I am dragging this whole scene. Okay. I didn't know I could do that. Haha. Haha. So if you're checking if your filter's in place properly, you want to check for continuity across it. So you could touch it here and here and see if you have continuity. But with this filter's not here, you will not have any continuity from here to here. So what we can do is touch R2301 and then our middle battery connector. And if we've got continuity across those two, we know the filter's in place and we're not touching the filter, getting a false reading. So looks like R2301 is going to be a no stuff, but we can still hit the probe point. And we have continuity, so that's good. Let's make sure we didn't do something stupid with our capacitor. Alright, that's good. Alright, so from here, let me show you what I was excited about. We have a rare unicorn of a board. This does not illustrate anything that I was intending to show with this video, but those in the know should appreciate this. Have you ever seen an SE where I don't know if they consciously decided to not underfill the crap out of this entire area, but look, TriStar and Tigris are free. They're just wide open. They're just, oh, it's amazing. Part of me hopes that we still have a charging problem and I need to change these. That's sadistic. It's masochistic. Look at all the heat they got on that battery connector. So sorry. Okay, let's clean it up. Clean, 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 all day long. Well, I guess I could have moved that little sticker that goes around the charging port connector. Guess I could have put it somewhere that it wasn't going to get waylaid by the hot air. But after all, it's just a sticker. It's not really doing anything. If they were really relying on that thing to prevent the charging port connector from grounding against all these components, that would be pretty shitty engineering. That's not to say Apple is innocent of shitty engineering, but that's something that like I would do if I was an engineer. I'm no engineer. Okay, it's solidified. let's give it the old 1-2. We taking bets on whether or not this thing behaves properly? We know it was completely unable to send battery data to the charging decision makers, which is TriStar and Tigris. And battery SWI line's open. It thinks there's no battery. I don't know what it thinks actually if that's open. It probably thinks there's no battery, except it has battery voltage, so it's got to do something. All right. Oh, do you see what I see? I think we got it licked. 3/4 of an amp. So sadly today we will not be taking advantage of this beautiful non-underfilled TriStar board. But the good news is we have a phone that charges properly and knows it's plugged in and knows what to do about the battery. I gotta wonder, how did it know there was 82% battery with the SWI line unplugged? Is there some secondary calculation going on in there? That'd be something for the smart people to answer. Because the way I was led to believe from everything I've read and experienced firsthand is the battery itself has a chip in it, buried up in this area, and it interprets the voltage properties of the battery to tell the phone what its status is. So now I'm confused as to why it knew there was 80% charge or 82% charge when it definitely wasn't seeing that battery SWI line. Couldn't have been seeing it. That's a research project for somebody. There's got to be some secondary calculation going on. Maybe since Tigris is present, maybe it's kind of backing up whatever the battery is telling it. Okay, we've got another 7 plus, also not charging. All right, here, known good charging port, known good battery. That's not the numbers I was seeing on my other charger. We're at 0.9. I don't know if I would call that bad. Let's go grab that other cable. What's a little bizarre is this cable will charge other phones at 1.5 amps. Let's see what it does on here. Yeah, check this out, 008. And just to show you, I'm not BSing. Not that one. Let's grab a phone we know is healthy. This one's in for screen repair, but it's healthy enough. Let's see if we got a bad cable here. If that's the case, then that'll be a. All right, now 1.3. So cable pickiness, and this is an MFI cable. This is a Amazon Basics. I cut open my cables when I order them. I'm not buying cables from Apple. I don't really care about giving Apple actual money. But if you order Amazon Basics branded cables, they are MFI certified chipsets. If you're not sure about whether your cable is legitimate or not, it's not MFI just because it says MFI on it. I promise you that. There's some websites for aftermarket cables that say MFI, and they even go as far as saying we have the chipset in our lightning connector, and they have a picture of a fake chipset in a lightning connector. So we're going to need to use this cable to diagnose, because if I plugged it in, if this was the only cable I had, I would say I think it might be okay. But if this was the only cable I had, I'd say, nah, that ain't right. 008, 009, not even close. Okay, let's start with TriStar. I'm starting with TriStar because I got a feeling Tigris is probably okay. If it can send that kind of amperage, I mean, it went to 1.1 briefly there. If it's able to send that kind of amperage, Tigris is the one that's actually doing that. It's actually routing USB to battery. TriStar is the one telling it, yes, do that, or don't do that. No, don't do that. But it's not responsible for physically routing the power to the battery. So let's throw a TriStar in here. Cable pickiness. There are so many symptoms of TriStar. The phone we had yesterday, I ended up really putting my foot in my mouth by the end of the video, because I started out by saying, this doesn't seem like TriStar to me. I'm going with something else. Because it was completely dead. The battery was completely dead. I was expecting to find a short on VCC main. It wasn't. It was giving weird readings. Sometimes it would read fine, 330. Other times it would be 260 or 284. But it wasn't short to ground. What ended up happening on that one was we had a combination failure, a cascading failure of Tigris and TriStar going out. And I blew up my first TriStar chip. By plugging it in and trying to power it on without replacing Tigris. After I replaced Tigris and TriStar for the second time, everything worked great. So let's pull TriStar out of here. This one's a little pain in the butt. Now, I used to cut this whole deal off, which it gives you way more access, and if you knock anything loose, it's going to be pretty much mandatory to do that. But I was watching other people's videos, and I just watched Jessa just kind of sneak hers out like that. I said, wow. That's why she gets paid the bid butts. Now, you probably noticed solder ball poop out the side there, so we are going to need to clean these pads up. Very often on TriStar, I just pull the old one and then drop the new one down right on top of the existing pads. You get a nice happy medium amount of solder, but because I didn't quite get it perfect just now, we ended up with a little bit of extra solder on one of those pads. And I'm just completely lost here. Yeah, let's get some more flux in there so this doesn't look so crappy. This doesn't need to be so hot. If you're working in a pool of flux and it's immediately evaporating and going dry, your iron's too hot. You want your iron melting solder and using the flux to its benefit. You don't want it drying out your whole work area. That's going to be counterproductive. Alright, let's see if we can look up in here. I want to make sure there's one more row of pads that goes all across there, and obviously we can't see them right now, so I'd rather not drop a new one in there blind, so we'll put our due diligence in. Okay. Yeah, those are a little big. Let's see if we can get to them. Do it by hand if we have to. Okay. Feel better about those. Yep. Our new TriStar ought to plop right down where it needs to. Okay, this is a 610A3B, which is just about all I have anymore. Where'd you go? Orientation is going to be north-south naturally as the board goes, so you don't want to go by the letters, but I haven't seen one yet where they weren't printed the same way. I'm sure the way that they have these set up to print I'm sorry for this shaky camera. We might have to do something about that. The way they print these, the dot is not printed separate from the letters, so dot goes up there. Alright, let's put a heatsink over the NAND. I don't feel like pulling that up today. We're not voluntarily pulling NAND chips up. Alright, so this it's a little too far clockwise. It ought to just pull right back over dead center. Find when it's slightly clocked like that, you're usually still okay because it actually helps the rest of the pads line up where the only way it can go is the right way, which it just did. Alright, I'm happy with that. Okay, let's see what it does. Plug our charging port in. Something to look at here. Plug our proximity and screen and home button in. battery last. Okay, and we're going to use the cable that was not acting right before. I know this cable's good. I'll just hold it up. Alright, what are we getting? That's even less good. That's even worse than before. That's not progress. Does it do anything with this one? No, nothing with that one. Did I put TriStar in wrong? Did I not plug the charger port in? Let's double check TriStar. Maybe I put it in wrong. No, A1. That's right. I knowed it. I knowed it. Let's double check this dot connector. Yep, dot connector wasn't all the way. That connector was smiley. Oh, you can't see what I'm seeing. Okay, so remember our cable that wasn't acting right? Now we're pulling 2 whole amps through that very same cable. There. This was the it's an OEM Apple cable. This is my 6-foot Amazon cable. We got 2 whole amps. So working under the assumption that Tigris was probably fine because it was still pushing over an amp at times. We went with a TriStar that was really picky about what cable it let charge it or not. Now that it's booted all the way up, let's see what the actual battery percentage is. Battery percentage, 43%. We're about 1.4 ish. That's about 1.4. Okay. Alright, so that's 2 down. I could get used to this. Easy fixes. The last few iPhone 7s in particular I've had with TriStar-like issues have just been a nightmare. I was getting a little concerned with this one until we figured out the charging port just wasn't all the way in. Alright, what's next? Take your pick. How about a quick touch IC? Hopefully a quick touch IC. I shouldn't have said that. I should not have said that. You know what happens when you get cocky. I could do a touch IC. I could do it real quick. I had one a couple weeks ago that got me a little too cocky. My shop closes at 6. Gentleman came in at 5:15. He said, "Man, I know you're closing soon. I was wondering if you could fix this." And he shows me a 6 Plus with, I mean, classic obvious touch IC. Gray bars coming down, no touch, all that jazz. I said, sure, yeah, you know what? I'll get this done for you. I started out with, yeah, go ahead and leave it with me. I can have it done for you by tomorrow evening. That's the under promise over deliver strategy. you give a realistic time frame that you know you can beat, and then when you beat it, you look like the good guy. If you can do the job in an hour, and you tell the guy an hour, and something goes left when it was supposed to go right, now you're an asshole because you took an hour and a half. If you tell the guy it takes 2 hours, and you still have to recover from doing something weird. There's that train. You still have to recover from I swear to God. I'm not going to bother trying to talk yet. Train's still passing by. Anyway, if you do the same job in an hour and a half, but you told them 2 hours, now you're the hero. Same job, same amount of time, even if the same Murphy's Law kicks in, you go from asshole to hero just by whatever expectation you set to start out. So, if that wasn't a long enough rabbit trail, I don't know what is. But anyway, I told the guy, give me 24 hours. He said, man, look, I barely made it here because I got off work early. I will not be able to make it back tomorrow before you close. This looks like pretty classic Touch, I see. He said, is there anything you can do? I said, you know what, man? If you're cool with hanging out here and not leaving, because I am going to be staying after we close. If you leave out of here and go home and I finish and you're not here, I'm going to lock the doors and I'm going home too. I said, if you want to hang out, I will take care of this for you. I'll get it done tonight. That was at 5:15. Well, at 5:45, I had him checked out and walking out the door. Perfectly good Touch IC. So after that, I got really cocky and shot myself in the foot a couple times with, still, 2-hour time quotes, but stuff that really required digging deep and fixing shit that I hadn't had to fix in a long time. Where'd my passcode go? So this one was sent with just a board. I didn't get a chance to really give my full mail-in instructions to this customer. If you send a phone in to a micro solderer, unless otherwise instructed, send the whole thing. Everything you got, fully assembled, every screw, make it look like you haven't touched it yet. That way when you get it back, it'll be like you didn't have to touch it. And he will have been able to completely diagnose and quality check all of his work. So when I get just a board, I'm going to do what I'm doing now, honestly. I'm going to plug in all my stuff and I'm going to test it to the best of my ability. But if you plug it in and your Touch ID doesn't work, when you get it back and you reassemble it and you knock something off or your proximity sensor doesn't work, my hands are tied. I wasn't able to test any of your stuff beforehand. Let's make sure front camera works. There's no back camera plugged in, but the front camera works. Obviously, we have no Touch ID. This is not this phone's screen. This is my test screen. Check, check, check. Test, test, test. 1, 2, 3. Proximity and ear speaker work. I can hear the ear speaker. Delete, delete. Yeah, we're not going to get that double tap. So, I mean, for the most part, everything we can test has been tested. We saw the gray lines. That was really obvious. So, this should be a textbook Touch IC. There I go again, saying should be a textbook Touch IC. Sorry, babe, I won't be home till 2 in the morning just because I said that. All right. Okay. Okay, all right. This little number here. How's your view? Could be better. Could always be better. Hey, going back to that 7, those dot connectors on the board, you've probably noticed, are really sensitive to whether they're plugged in perfectly or not. So the whole problem we had, looking for my good tweezers, the whole problem we had was because there was a slight little smiley shape to the charging port connector where it met the board. So once I straightened that out and got it seated perfectly, it was great. It was no problem whatsoever. So don't let a part troll you. Okay, we're gonna go Gorilla Hot. That's not really a unit of heat measurement. This is a big letter touch IC. Are we feeling superstitious? It's also got a chunk missing out of it. I'm thinking yes to superstition. We're gonna get this out of here, and I'm gonna replace this one. I'm thinking yes to superstitious about big letter touch ICs. Maybe it's not superstition if you've gathered enough evidence to support the idea that the big ones don't like being reballed or reinstalled. Well, I guess we should put that back on the SE. EMI shields, yeah, put them back. If you take any pride in your work, you better put the thing back how it came. Within reason. Okay, scrape, scrape, scrape. Make a new pad. Put some solder on the pad. I don't think there's any solder on the iron right now. It's okay. It's one thing we'll probably never run out of is solder. I have one roll of solder, and I've been using it for 5 years now. I actually have like 3 rolls of solder. I was obsessed with finding the best solder. And for me, the best solder is 6040 Radio Shack Rosencore solder. Just basic ass solder with a little bit of flux in it. It's got to have lead in it. That's what's important. It's got to be leaded. You can get stuff with silver if you want. That's good. It's all gonna be tin and lead, and some of it will have silver. I think the silver is some of the higher melting point stuff. I just like the tin and lead solder. Great general purpose stuff. It's been around for years. It works. If anybody has a reason why not to use it, I want to hear it. I need to hear it. Haven't heard any yet. unless you're ROHS, then obviously you only want me using unleaded solder, but I don't answer to you. I should probably not call out regulatory bodies. Maybe I will not. Maybe I will not challenge the authority of a government regulatory body in my workplace. Everything we do is ROHS approved methods. Take great pride. This is a little off there. Alright, so we decided we're not going to put the big letter chip back down. I'm going to set it over here, and maybe if I have a phone that needs a donor. I had 2 water damage data recoveries this week that needed Mason chips. It's really interesting, and it was actually the exact same circuit on both of them that got damaged. It was PP1V8, which is let's look. Hope you don't mind going off on weird tangents. PP1V8, which is like, nope, god damn it. It's here. This little fella right there. N3. And then there's a pair of them up here. But this pad on both of my water damage phones that we got data off both of them. BT dubs. But yeah, it was real muddy, saturated, nasty liquid all up in this area. And that N3 pad was heavily corroded on both of them. PP1V8 is one of the first things to come alive in the phone. It's like a reference line that enables everything to turn on. So that does make sense that would corrode. Alright, so we have a small letter chip. I've decided to go ahead and reball this one. This is it should be a brand new chip, but that's not my solder balls on there. Those are probably better looking solder balls than mine, but they're not mine. So my paste is going to melt at a significantly lower temperature than what these are, and that's exactly what I want because we just made that little jumper. And really the last thing I want is for this to get hot enough to displace my jumper. So I'm going to go ahead and reball this chip that has perfectly good balls because I want lower melt solder on it. Get all this stuff off of there. Okay. Put that away. Clean and dry the chip. Clean and dry, dry and clean. Good old 99% isopropyl alcohol. That's my cleaning agent of choice. There's still a little flux. There's still one ball right in the middle there. It didn't really get fully absorbed. I think it'll make the trip though. See what it looks like once we get it reballed. If it looks like shit, well, I'm really wasting Mostly my time, a little bit of yours. Alright, paste. Actually, no, I have not gotten data off both of them. I got touch back on both of them. One of them, I'm still trying to get data back. While the touch was not working, it would establish a connection to the computer through USB. As soon as I got the touch working, it's having trouble with its data connection to the computer. It's an interesting one. Debating whether I want that one on camera. Let's do one thing at a time. Let's make some money with a touch IC. I left this paste out all night and it's still wetter than I want. Look at this top right ball. That's not gonna work. That one is not gonna cut it. I'm gonna cut it down. I'm not gonna do it with that. I'm actually gonna literally cut it down. Might as well cut them all down for doing that. Alright, well, spread a little paste, fill in the gaps. Yeah, this stuff is way wetter than I want it to be. It makes this more difficult than it ought to. Nice dry solder paste, that's what we want. Want it dried out, almost like Play-Doh. Yeah, this is just a mess now. Just a mess. Come on. Follow up. Well, those at least look better than the last set. Yeah. That funky one in the middle is at least behaving. It's not a total loss. Let's clean this up. No, Flux has got it. We'll warm it up a little bit. There we go. Why? I know why. It's my own fault. Boy, there's a lot of residual solder paste in this stencil. I need to give it a good solid clean one of these days. Okay. Let's do this. We'll clean this up one more time. I don't want any of that fairy dust getting in there. Okay. Not enough to significantly change the size of our solder balls, so everything's still nice and consistent. So we can turn our heat down on the air. We'll put this where it belongs. Heatsink action up there. Okay, that's good. That's it. Clean that up a little. Okay. Alright, let's give it the old Ferrari Testarossa. I'll put these away before something happens to them. Screen battery dock. We'll switch this over. Plug it in. The lights are on, that's a good sign. I always like to say I didn't break the phone when I was working on the board. Passcode. Okay, let's check for full touchscreen operation. Okay, we got no dead spots. Everything's sturdy. Let's go to our front camera. There's no rear camera. Front camera, that's good. And we'll do voice memos. We'll test as much as we can, which is not a ton, but check, 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 test, test, test. 1, 2, 3. Proximity, sound. Okay. So everything that was working before is still working now. So we'll call that a successful Touch IC job. At least I don't have to put this one back together. It's just a board. Okay, and think we can go ahead and call it there. That was 3 fixes in about, I don't know, what was that, 45 minutes? An hour? I don't know. I got some housekeeping to do, put these all back together and have them ready to ship out. So thanks for watching. It wasn't a whole lot to learn from this, but killed some time and fixed some phones. Farewell.